All right. Well, thanks, Eric, and everyone for setting this up and for attending today. I am presenting now on bacteria control planning, and it's in this nice webinar series on bacteria and microbial source tracking technologies. This presentation is well set up by the previous presentations by Eric on sanitary survey procedures and Darcy on network investigation procedures in MS4s and microbial source tracking study design. So I'm going to kind of not reinvent the wheel in those presentations and try to build off those and help agencies understand how to interpret results from those studies into concrete action plans for bacteria control. So there's a lot of different ways could have taken this. I'll focus on describing and documenting the state of the practice as it's reflected in existing available resources and guidance, then talk about some case studies, and then try to wrap things up with takeaways and recommendations. And where to begin on available resources? Well, on BMPs, especially structural BMPs, the commonly accepted resource that is most comprehensive and most used is, as I believe, the BMP database, International BMP database, can be found at bmpdatabase.org. And there are nice fact sheets there. I'm showing one of them here from December 2010, which is we call pollutant category summary, essentially a fact sheet on bacteria. And it not only compiles all the bacteria performance data of structural BMPs, but it also has narrative discussions on sources of bacteria and non-structural BMP selection for bacteria control. Also, the topic of today's presentation is a topic of an article that we wrote in Stormwater magazine originally in 2012, and then it was reissued, reprinted in 2016, and that is shown here, and you can Google that document. So feel free to access that article in that trade journal for more information on non-structural and structural BMP planning and selection for bacteria. There's also a ton of plans that are out there for bacteria compliance. So armed with a quick Google search, you can find in the Central Coast, they're called TMDL waste load allocation attainment plans. In many regions, including the LA region, they were previously called TMDL implementation plans. In the LA region, more recently under the current version of the LA County MS4 permit, they are enhanced watershed management plans and watershed management plans. And then in the San Diego region, there were previously the combined load reduction plans and now the water quality improvement plans. So there's different acronyms, different names in each region, but essentially these plans outline the planned activities that the watershed groups and MS4 agency groups intend to implement in order to meet the recreational water quality standards. And I think what the casual observer will observe when they look at these in totality is that each one is so different. I should say each one is so different across regions because the region by region expectations are starkly different. So, the ones in the Central Coast Board, which are mostly for Phase 2's agencies, those are mostly non-structural BMPs. The costs to implement them are very small. Those that under the LA Board that were enforced through numeric compliance assessment means, those have to undergo extensive reasonable assurance analysis modeling. So those are heavy in green infrastructure, and the costs are huge. I think the total cost, most of which is driven by bacteria, is on the order of $25 billion or more across the LA region. So why is there such region specific variation? It's because of the specific and unique expectations of each regional board. So a key question as you start down the road for bacteria control planning is, how much regulatory flexibility do you have to limit your controls to essentially pathogen sources, which are what affects recreational public health, or are you actually held to controlling all sources of fecal indicator bacteria? That's a fundamental starting point. Without the answer to that question, then it's hard to move on intelligibly. So another guidance that we produced, I was co-editor with Dr. Pitt and from University of Alabama, and Jane Clary from Wright Water Engineers, is Pathogens in Urban Stormwater Systems Report. It's a guidance manual written for the American Society of Civil Engineers, Environmental Water Resources Institute, and the content is shown here. This is the table of contents. It talks extensively about the topics that are in today's theme: source tracking, non-structural controls, or we call them source controls here, structural controls, and then case studies. So I would refer people to this. It's a freely available resource that's available for download at this website at EWR Institute. And we actually were then hired by ASCE to present these to their nationwide membership through the ASCE Learning Series. So the webinars are also available, and those are great resources as well. So I'd point attendees towards those webinars, which can be found at this mylearning.asce.org location. We presented those webinar series 2 years in a row. Then, most recently, we produced for the state of Colorado and the Denver metropolitan area agencies what we call the Colorado E. coli Toolbox, which is it's essentially a leaned down and more current version of the pathogen report for ASCE. It includes a similar content, source tracking, source controls, structural controls, and this is freely available for download at the Urban Drainage Flood Control District website. So you can see the link there. So I would advise folks to take a look at this. I think this document best reflects today's state of the practice for bacteria control planning, and includes a lot of kind of information that can't be found elsewhere on microbial source tracking study design and network investigation within MS4s to locate sewer inputs, and advanced design amendments to certain technologies like biofilters to get more bacteria removal out of them. So great resource there. So what I'm going to do essentially moving forward is talk about the content of those guidance, especially the Colorado guidance. And it starts with what are some common sources of bacteria and nutrients in urban stormwater. I add in nutrients because often these are coming hand in hand. And so where you can control recreational public health issues, you can also control eutrophication often. So this is a real two-for-one kind of situation. So we typically bracket or categorize sources of indicator bacteria and pathogens into three categories based on their risk and controllability. So first category is human waste sources, like sanitary sewer overflows, leaking sewer pipes, illicit connections. Those that are anthropogenic in nature but non-human fecal, things like pets and livestock, rodents, and then the dumpster waste and trash cans, excluding the diaper side of that. And then things that are low controllability, low risk, and that is the non-human sources that are independent of human activity. And those include, besides wildlife and birds, they really include the large amount of environmental sources of fecal indicator bacteria, which may constitute the majority of fecal indicator bacteria loading in watersheds in wet weather. So understanding your sources, that's the first step of any process for bacteria control planning. And so moving on, once you know your sources, prioritizing them for then planning your controls is the second step. And we typically do that based on a number of different factors, which are documented in the Colorado and ASCE guidance manuals. But the most important factors are typically controllability and risk. And I think it's pretty well understood at this point that human waste, as shown here in this QMRA publication by Jeff Solar back in 2010, sewage is the greatest sources of risk among non-human sources. An exception here is with cattle. I guess there's just a lot of human pathogens found in cattle waste. But compared to gulls and, I'm assuming, domestic pets and other wildlife sources, the pathogen content of human sewage is much greater. So this is something that we want to prioritize in urban infrastructure to control. So infrastructure-based sources of human waste should be a top priority of any bacteria control program. So now you've identified your your sources in your urban area, you've identified, you've prioritized them, and now you select first non-structural BMPs to target them. So based on your prioritized sources, now you align your non-structural BMPs to hit or address each of those sources. These are selected based on your local prioritization and local knowledge. As you can imagine, non-structural BMPs are lower cost than structural BMPs, but little performance data is available on them. It's rare that you have published controlled studies on the water quality effectiveness of implementing different non-structural controls. One exception is actually in Santa Barbara. My colleague, Dr. Irvin, he worked with the city of Santa Barbara to do an outreach effort to creekside residences to target pet waste, and then they measured the dog marker before and after that activity and found a significant reduction in dog markers. So it's rare that you have controlled studies like that published. And another thing that I'll note here is that the regional board expectations on what is maximum extent practicable, that is a standard in MS4 permits across the country, that varies widely. So it's really best to confer with other MS4 agencies in your region to understand their interpretation of maximum extent practicable, because everyone asks us, well, how much is enough? How many non-structural BMPs is enough? And so on. Non-structural BMPs are much harder to quantify than structural BMPs. So the answer to how much is enough, well, it depends on what your regional board expectations are. And then the last note here is that with respect to dry weather, flow elimination, so after you abate your illicit connections and leaks and other human waste sources, eliminating dry weather flows to the extent possible is really the only sure strategy for demonstrating permit compliance with receiving water limits in dry weather, because you break the cause or contribute linkage, and you cannot be found liable for receiving water quality standard exceedances if you have no discharge, and that's documented. So I just want to make a point that that's a great strategy. And one of the first steps in abating dry weather flows is to identify and document where they're coming from. This then allows you to guide your things like water waste ordinance prohibitions to know which prohibitions to include, and allows you to then target your water waste outreach and inspection programs to target these specific sources within your jurisdiction. Okay, let's talk briefly about structural BMPs, and then really I want to move on from that and focus on human waste controls. So retention is the most effective of BMP types. That means infiltration and capture use. Of the flow-through natural treatment options where there's a discharge at the bottom of the BMP, biofilters or bioretention and subsurface wetlands are typically found to be the most effective. And I would point folks who are looking at biofilters and bioretention for bacteria purposes to Monash University's facility. That's a university in Melbourne, Australia. They have a facility for advancing water biofiltration, and their design guidance is as advanced as anywhere in the world. So I point you to that website for some of their design advancements. But a key takeaway here with structural BMPs is that there is no flow-through treatment option that's currently available, as far as I'm aware, that can consistently meet the recreational water quality standard, with the exception of disinfection. That's a really important takeaway. I'd also note, because we get a lot of questions about proprietary devices, so it's key that you vet the proprietary device vendor performance claims. I've seen performance claims exaggerated because the test conditions are in a laboratory and using synthetic stormwater, not real stormwater. And so there's a lot of real-world conditions that are missed in that work. And I've also seen where there's toxicity export concerns. So you really have to look for independent field studies to vet those two issues. And technically, it's illegal to install a proprietary device in California without the Department of Pesticide Regulation approval. So that's required for antimicrobial devices, so make sure any technology you purchase and install is approved in the state of California. One other thing I'll note about things like bioretention, where you have inflow, outflow, it's not all about concentration reduction for bacteria. You also want to take credit for and acknowledge the volume reduction benefits of those BMPs. So what we're showing here in this lower chart is that when you bin the precipitation events that enter the bioretention device, the percent of inflow that is fully captured, it's very it's very high in the smaller storms. So smaller storms are effectively captured and prevented from discharge. So there's a volume reduction benefit as well. Okay, now let's put aside the BMPs that are laid out in available guidance and talk a little bit about infrastructure sources of human waste. Within an MS4, we typically call this illicit discharge detection elimination. And different permits and regions and permittees view IDDE differently, but the sewage illicit discharge aspect of IDDE programs is what I'm specifically talking about here. And it essentially follows two steps, and that's an outfall prioritization step followed by a network investigation step. So the outfall prioritization step, to be effective for eliminating human waste sources, would use sewage surrogates like fecal indicator bacteria or human markers, even better, more sensitive, as we learned in previous presentations, and more specific to human waste. Once outfalls are prioritized, this is a flowchart that we're showing here that basically describes what I'm discussing, is something that we presented to San Diego County and then summarized in our ASCE manual and in the Colorado report. And the network investigation steps then incorporate these conventional subsurface investigation tools, things like dye, and then using GIS. I'll show what I mean by that. CCTV, and then sampling of fecal indicator bacteria. These are the things, when using combination, they allow you to locate inputs into an MS4 network. Human markers are going to be the most accurate measurement of whether your IDDE program is effective. That is it effectively identifying and preventing waste inputs? Is it reducing it over time to a point where there's a de minimis amount of sewage conveyed through your municipal separate storm sewer system? And therefore it's going to be your most reliable means of verifying whether illicit discharge have been abated. So let's talk about what I mean by that in a very practical sense. For the city of Boston, we recently evaluated their ID. They had a very mature IDDE program that they've been implementing for decades. They have a lot of gallons of sewage that they track, that they have found through private and public connections and sewer leaks into their MS4. You know, you can imagine the city of Boston, old city, old infrastructure. And so they have measurements of gallons of sewage that they've caught and prevented from entering their system. But what they had no idea of was whether their progress over the past couple of decades has gotten them to a point of where the remaining flows in their MS4 are absent sewage. So we came in and used MST to essentially evaluate the effectiveness of their IDDE program. And interestingly, we found what we're showing here are log order magnitude copies of the HF183 marker across different subcatchments or MS4 outfalls, and we grouped those outfalls by whether they had IDDE programs complete and the follow-on corrective actions complete. And this is where we would have expected to see low human markers. We found pretty high human markers. The non-detect is shown down here. 100 is usually the limit of quantification. 1,000 is considered roughly a health-relevant level based on recent publications by Stoller and Bohm, Stanford. So these are relatively high concentrations. By comparison, sewage is shown over here on the right. Sewage is about 10 to the 8th of HF183. So we're talking about concentrations up to 1% sewage over here. This is where IDDE and corrective actions are complete. So that's not good. Then where the actions are, IDDE is complete, but the corrective actions are not complete, still finding across the board sewage being conveyed in the MS4, and where actions were not complete and IDDE is still ongoing, which is where you would expect the human marker concentrations to be highest, they ran the full gamut. Then for wet weather, we found, interestingly, that the human marker levels were lowest. So there's a few takeaways here that are interesting. One is that human waste is present in the MS4 discharges during dry weather, regardless of IDDE program status. That means further IDDE program improvement is needed. And secondly, When you have lower human marker concentrations in wet weather, that tells you that the land surface contributions, the above ground contributions, things like open defecation on the land surface and homeless encampments and spills and sanitary sewer overflows, these are less significant than the below ground infrastructure sources, things like sewage leaks and illicit connections. That tells you where you need to put your resources into further to yield further human waste reduction benefit. So we said, okay, well, what's not working? Which parts of the process of IDDE in the city are not yielding the outcomes we want it to yield in terms of getting to a point of human waste abatement? So we looked at how is outfall prioritization done? Well, outfall prioritization here was done using fecal indicator bacteria. We looked at the correlation here for dry weather, E. coli versus HF1A3. There was a decent correlation. When you categorize these into quadrants, we can call the associations false positives, true positives. So, for example, when E. coli exceeds their threshold of that they're using for outfall screening, but there's little to no HF1A3 presence, that's a false positive. Where there is significant human waste marker present and E. coli exceeds your screening threshold, that's a true positive. That you then prioritize the right outfalls and enacted network investigation. Now, on the other hand, there's true and false negatives. So when E. coli is below the screening threshold and they then the responsible party does not take on network investigation to locate where human waste is entering, that's a false negative when we found that there actually was human marker present and high. So we can see that 14% of those samples, they were false negatives. So that's unprotective. And then of the true negatives, 86% of the time that they were making the right decision. So it wasn't terrible. HF183 had a decent success rate, better than what I would have thought. In wet weather, it is atrocious. But compared to where we've done this similar correlation in California, it was much better. In California, we tend, in dry and wet weather, to see little to no E. coli to human marker correlation. And that's because we have lower levels of human waste in our newer infrastructure. Here we have higher levels of elevation and higher levels of human waste present and older infrastructure. Okay, so the outfall prioritization process was working there. That wasn't the problem. Where the problem was is in their network investigation. That's where improvement was needed. So we looked at how are they doing network investigation? How are they working their way up MS4 networks in an ultra-urban environment across large areas, many miles of MS4 to locate where illicit connections and leaks are entering their system? And we found, they're using a series of test kit parameters. Most notably was ammonia. They had ammonia surfactants and residual chlorine. Residual chlorine was almost always non-detect. Surfactants was a scattershot and had limited utility. But ammonia was a primary parameter, and it's generally believed to be associated with sewages in urine and things like that. So we looked at the association between ammonia test kit measurements and the human marker and found really unacceptable correlation. So that means that when they were in the field, to use the test kit, which is nice in that it's super cheap and it's an immediate result that tells you, do I need to do a dye test in a sewer line nearby and notify property owners that they may have an illicit connection that they need to correct? Well, they have true positive 75% of the time, false positive 25%. Okay, not horrible. Still, it's a better than a coin flip. But false negatives are having almost 70% of the time. It's just too insensitive. So on the bottom end, ammonia is too insensitive, and on the top end, it's not sufficiently specific. It has false positives a quarter of the time. A quarter of the time, they're using a test kit and chasing after waste that really isn't there at significant levels. Sometimes it's completely non-detect. So that means that this is coming at a cost to their program, a cost in terms of labor effort. And even though the ammonia test kits are much cheaper than HF1A3 per sample, the labor cost makes up for that difference that that cost loss, and it also means that the program isn't as effective as it could be. It's not yielding complete abatement of human waste in their discharge, which is a goal of the cities. So this is a recommendation for improvement that we were able to work with the city to identify, and basically forces them away from a position where they're using a coin to flip to make a decision of whether to chase after waste that is or isn't there. So as a summary of this project, we evaluated the effectiveness of their existing program. It actually just won an award from the National Association of Clean Water Agencies. So that was nice recognition. We recommended refinements to their network investigation procedures. For time reasons, I won't go into details here, but you can follow up with me if you want more details on that. And as a result, which, it sounds like that's bad news. You're discharging more human waste than you thought. You had been implementing an IDDE program for 15 years or more, and there's still human waste present. There's actually a very positive side of that, because you're currently at a point where they had bacteria and nutrient TMDLs that they were measuring progress towards. They have waste load allocations that they're assigned to. And now what we're saying is that you have all this low-hanging fruit through IDDE programs, which are ongoing implementation costs are much less than green infrastructure costs that they were facing, that they were estimating as needed to comply with the TMDL requirements. So that means that they can now expect to yield a lot more phosphorus and bacteria reduction through enhancements to their IDDE program and comply with TMDLs for using less green infrastructure and save costs. So that was, in that regard, it's actually very positive news. So one of our recommendations in the network investigation was to have greater use of GIS. And here's what we mean by this. This is a project that we did in San Diego County, and we also did this in Santa Barbara. In using GIS to support the network investigation, at outfalls that have been prioritized using DNA markers, we overlay the storm drain and sewer maps to understand the pipe material age and invert elevation relative to storm drains. And basically where sewers are above and near storm drains, you visually determine where you identify those as, quote, at-risk crossings. And then through a visual assessment of where the MS4 is flowing, it allows you to focus your CCTV on those at-risk locations. If you see a leak from the side or the top of the MS4 pipe at those locations on your GIS maps that you carry with you in the field, then you know that there's a sewer line that runs nearby and maybe the cause of that flow into your, as you often see flow in when you're CCTVing MS4s at the joints. So this is one of the tools that we're recommending to incorporate into their network investigation procedures to yield more illicit discharge elimination. Okay, some more case studies. Moving on, in Santa Barbara, we're working with UCSB under a state water board Clean Beaches Initiative grant at across 3 beaches in Santa Barbara and Goleta. And this is building off a previous investigation that we did with UCSB and Laguna Channel, which was the first to document and publish on sewer exfiltration to storm drains. So that's this kind of famous figure you see here in the bottom left, and that shed light on this really important source for agencies nationwide, which until then wasn't really being talked about. Now, the local infrastructure sources in our ongoing study, more recent study at these beaches, they've been thoroughly investigated now. CCTV and GIS and dye and florimeters and human markers in groundwater. What we're showing here on the bottom are locations where we installed through hand auger little wells on the beach, and then also samples in the surf zone for the marker and a dye after we popped it into a sewer line, and we're able to evaluate if any of the sewer infrastructure or bathroom infrastructure is leaking there. And hand augers are just so easy to put alongside streams or at beaches, so a really nice tool to use to test a hypothesis of whether underground infrastructure is making its way through groundwater into surface waters. It's also perfect for septic investigations. And based on this study result, we're basically finding local infrastructure sources are not contributing here. There are human marker detections in the surf zone during dry weather at very low levels, and we're continuing to evaluate the homeless and bather sources. And that's going to produce management actions that are being developed based on the study results that allow us to improve public health protection at these beaches, which are high tourism beaches. Here, if we're confirming our hypothesis, that means that there'll be potentially recommendations associated with homeless outreach. At night, the beaches are used here for homeless sleeping, and so there could be more enforcement or outreach there and coordination with NGOs that provide shelter to provide education to those people to let them know that there are shelter spaces available nearby. And we also have very common at this location triathlons and things like that, so encouraging showers for the race operators before people enter the water is another good thing to help control bather shedding. And then there's also marina areas nearby that are under review. So another case study, Ventura River. This is interesting in that this is a nutrient source tracking study, but understanding septic as a waste and a contributor of nitrogen. This is being done for the Ventura County Environmental Health Department under a state water board grant. And here the driver is not a bacteria TMDL, but an algae TMDL, as well as a statewide septic policy, which combined for this watershed was requiring watershed-wide upgrades from septics to costly on-site wastewater treatment systems. That becomes a nightmare for electeds. If you're telling your constituency that there's environmental regulations that are forcing homeowners that are living in rural, unincorporated county areas that they're going to have to pay $50,000 a head to upgrade to an on-site wastewater treatment system, they're going to be up in arms and they're going to go right to their elected officials. And the first question they're going to say is, how do you know it's me? So this study is answering, well, whether we know it's you. And this is using a combination of groundwater surface water sampling of nitrate isotopes, and chemical sewage markers. Here we went away from the DNA markers because in subsurface, when we're trying to understand nitrate fate and transport, it was our belief that the chemical sewage markers would be more recalcitrant, it would be and more mobile. So whereas the DNA was is subject to die-off and potentially more rapidly than some of the chemical markers. So we're using chemical markers, and the sampling locations are selected based on travel time and geology. We want to make sure we characterize bedrock areas and alluvial areas. And we're also doing a related project for the State Water Board now to model the groundwater surface water interactions, and this allows us to more quantitatively understand the nitrogen fate and transport from these land application sources, which is really the focus of the TMDL. That's ag, fertilizers, ranching and equestrian activities, and septics. And then as a result of this, we're generating management actions for the septic owners, which is essentially, actually it's not for the septic owners, but for the septic regulator, which is environmental health, who then communicates it to the septic owners. And the management actions here would essentially consist of recommending sewer connections in certain areas where that's feasible, or certain targeted use of on-site wastewater treatment systems where those sites have greatest contribution to surface water nitrogen levels. And that those recommendations are to be determined as soon as our study results become available in the next couple of months. Okay, so gave a presentation on MST IDDE in Boston, gave a study on beach sources in Santa Barbara, gave a presentation on nitrogen transport and septic contributions in Ventura River. Now here's one from a watershed planning perspective, more of like a high level, less in the weeds of sources and study design elements, but talking about the overall planning and control strategy development. We've developed a lot of enhanced watershed management plans, water quality improvement plans, TMDL implementation plans, but one that is more recent and stands out to me as one that was particularly rewarding is for South Orange County, where we were able to take a different tack at attacking bacteria. And like any WQIP where bacteria TMDLs are in play, our objective here was to attain the bacterial water quality standards, which are expressed through TMDL wastewater allocations within the MS4 permit. And this was the first WQIP or EWIMP, for that matter, to implement what we came upon was a human waste control strategy. So we went away from treatment of stormwater as a whole, which conveys a bunch of sources of fecal and environmental non-fecal sources of bacteria. And we went towards just saying we want to focus on what are the sources of recreational impairment, and that's pathogens, and that's coming from human waste primarily. So, and that, as a result of that, it actually reflects significant cost savings. I think it's up to $600 million, what we're talking about there, compared to a conventional wet weather structural control-based approach, which we kept as a backstop if the human waste control strategy isn't accepted or doesn't work. So one way we communicated this to the stakeholders, including the regulators, was that we have a choice here. We can go with the traditional implementation approach, which focuses on fecal indicator bacteria, which uses structural stormwater controls as the primary implementation strategy. Or we can go with a new implementation approach, which focuses on health risk reduction, consistent with the direction regulations are taking, with human waste control as the primary implementation strategy. Both use microbial source tracking, but the traditional approach, like almost every or every other EWIMP or WQIP that's out there, including those done by us or others, it relegated MST to this ancillary, quote, special study realm, where it's kind of used more as like a regulatory modification tool. Here, what we're saying is, no, we want to use MST as an implementation tool to allow us to comprehensively identify and locate human waste sources and abate them in the watershed. So I think that played pretty well. And we developed this new implementation approach process, which is essentially focusing on dry weather human source investigations first, then based on where we find sources to control those dry weather sources that are identified. Then once we abate the sources of human waste that are found, fixing leaks and illicit connections, addressing homeless waste where it's found to be significant, and any other illicit discharges, we then verify. Verification is critical to conclusively demonstrate that you've abated the source. And then, if we show with verification sampling that we're not done, we go back to the drawing board at step one. If dry weather human sources are eliminated, we move on to wet weather. It's critical that you don't move on to wet weather too soon, because wet weather sampling using MST markers is this amalgamation of land surface and below ground sources. So there's too many variables for you to act on the results that you get. Once wet weather is done, if wet weather is then clean and dry weather was previously shown to be clean, now you're at a point where you can have a viable conversation with regulators about what are your regulatory options. If it's not, if you're still exceeding the bacteria standards and there's no regulatory off-ramp available to you, then you move on to that structural BMP as your backstop, and that's back to the traditional compliance approach. So this is the path that we laid out. It leverages MST to rigorously pursue sources. We recognize it's a multi-year process, which the TMDL compliance schedule allows, and it includes verification sampling. I think most MST investigations don't include that step, but it's critical because it's how you know conclusively and how you can show that abatement was complete. So the advantages of this, as you can imagine, is there's greater health risk reduction because you're aggressively reducing human waste sources that are higher risk and also more controllable than the non-human sources. It's lower implementation costs, so it requires less public funding, and it's in line with EPA's movement towards health-based criteria. And it's also consistent with various ongoing efforts and studies across the region. So Surfer Health Study is finding that illness risks in surfers were low in wet weather, QMRAs that are showing that non-human fecal sources are of low health risk relevancy, and the cost-benefit analysis, which I'll go into next. And then it keeps that insurance policy that the NGOs and the regulators want, which is structural stormwater BMPs as a backup plan. So after the WQIP was submitted, the San Diego cost-benefit analysis was completed, and it confirmed the benefit of this strategy. It looked at the avoided illnesses that are shown here between two different implementation approaches. The default implementation approach for bacteria TMDLs, in this case quantified for the San Diego Regional 20 Beaches and Creeks TMDL, versus the avoided illnesses that are anticipated from human waste control-based strategy, like the one I described for South Orange County, and then it compares the implementation cost between the two. Here is $2.75 billion to implement the conventional approach, but a human waste control approach was almost half that. This is an elevated estimate of the human waste control approach because it's assuming that there would be housing paid for every homeless person in San Diego County. So you can imagine that's That's the majority of this cost here. So what is it saying? It's saying that there's greater benefit of a human waste control approach and lower cost. I mean, that's kind of a no-brainer then. It's consistent with what your intuition would be, right? If you have stormwater BMPs, green infrastructure that, like, most of that money is in the form of green streets. Green streets are taking sheet flow runoff from above ground, people's driveways and roads and roofs. Never once did that get contaminated by illicit connections and sewer leaks. Whereas if you have an approach that uses our most sensitive technology, DNA markers, to locate where the inputs are into the storm drain system and abating those, then you're directly eliminating pathogens that are causing disease. So this analysis is one of several inputs into a bacteria TMDL reopener, so it's being considered there. And they monetize a broad array of benefits, societal benefits, economic issues, recreational the benefits associated with keeping beaches clean, the tourism benefits associated. So it was really comprehensive at looking at the costs and benefits, the monetized benefits, including the illnesses avoided. And the sum, even after doing that, the sum of those benefits was far exceeded by the cost of implementing the conventional approach. So the alternative human waste control approach was found to be favorable. Again, I think that's confirmed by people's intuition. So final two slides, takeaways and recommendations here. For bacteria control planning in a watershed, it's hard to give something that's really general for any watershed, but I'll do my best here. First, focus on dry weather. There's fewer variables to control. Focus on the highest risk, most controllable sources. That means human waste from infrastructure. Use MST markers to guide implementation. People often think of MST as a regulatory modification tool. I like to talk about it as an implementation guidance tool. Expect human waste and infrastructure sources. It is the norm. I think a lot of people enter MST studies expecting the opposite. Involve the infrastructure owners and operators early in the investigation process. So if you're a beach manager, you involve the sewer and storm drain owners. If you are a MS4 then agency, then you involve the sewer owners and operators. You want to mine local knowledge, and two, you want to be working collaboratively with the infrastructure owners. Third, under this bullet, human markers may have a higher analytical cost, which I think scares off some users. But consider the labor costs of cheaper methods like test strips, that are low sensitivity, so they're missing waste, and they're low specificity, so they're flipping a coin in the field, sending you on wild goose chases. That's an inefficient and ineffective IDDE path. When designing an MST sampling plan, remember it's harder to prove a negative than it is to prove a positive. So that means more samples are needed for, say, a natural source exclusion demonstration than the number of samples that are needed for source investigation. If you want to investigate sources, you may only need 3 to 5 rounds of samples. But for demonstrating absence, you might need, I hear people talking about 30 plus samples at a location. Non-human markers typically aren't a useful line of evidence until human absence are shown. I get a lot of requests for paying a lot of money for non-human markers, but typically that information isn't helpful until you get to the point where human markers are gone, and that takes a while. So I wouldn't even recommend wasting money on that in the beginning. And then last here on MST studies, really recommend using experienced personnel to support proper hypothesis-driven study design, proper guidance on sample collection procedures, and then proper interpretation of the results. Last slide on takeaways and recommendations. For BMP planning, recommend following available guidance, which I cited here in this presentation. Where possible for dry weather, pursuing discharge elimination to ensure that you get permit compliance, and exhaust your non-structural lower-cost BMPs before moving on to structural wet weather controls. Lastly, we always get asked this question, well, what do I do about bacteria? Is this going to bring me into compliance? Well, bacteria may never meet the recreational water quality standards 100% of the time, especially in wet weather, even after you've abated all your human sources, just because human marker and bacteria sources are different typically, especially in urban areas. So there are regulatory pathways available, like site-specific objectives, but know that it's not a quick fix. It's not easy to get. The process is lengthy, it's costly, it's uncertain. Have any been done? No, there have not been any done yet. And the first test cases in California are still moving through the pipeline. So with that, thank you, everyone. And it looks like we might have 1 minute. I don't know if I'm happy to stay late to to answer questions, but I'll open it up. And here's a link for a fun little YouTube video that we put, a whiteboard video that we put together on the human waste control approach, if you want to check that out at your leisure.